we're going to build another calculator to help us quickly and easily find the safe beams for different lengths and weights. I'm going to run you through the example real quick, and then I'll show you how to apply those equations we solve in the example in our new table. So, as I said, these are columns now, or did I even say it? If I didn't say it, that's what we're doing, is columns, not horizontal beams, vertical beams. Columns. It's like this. See, this is a column. This is a row. Do you understand? Okay. So, we've been doing length, so it's the same thing. I'm just calling it height now. So when you see the little L in your equation, that's the same thing for length, or for height. So I could probably just, I'm replacing the H there with the little L. So from the example, we have a, where's that at? It's a 14-foot high beam. The beam type they're going to have us use is a W10 by 49. Let's see if I can find that real quick. There it is. We can find the area from the example or click over to our beams. W10 49. And there is our area right here. Press enter. So this Rx and Ry, your radius of gyration, on our chart here is the Kx and Ky. So I'm going to press equals. Go over here. There's Kx. 1049 Kx. Press equals again. Ky. 1049 Ky. Press enter. Now your minimum R, your minimum radius of gyration, is what we're going to put here, and that's what we'll be using in our equations. So either you can just select the small one, or if you want to have fun with some Excel, it's min, select here, and here, close parenthesis. Press enter. That was a lot of work for nothing, but whatever, I like using Excel functions. Your effective length factor, which is K. For all of our problems, it's going to be 1. If you look at the figure 6.4 in the text I included, it's a little hard to read. If you want to really look at it, I have another book that includes all that. That's just the different types of end conditions. So on ours, it's going to have, our end condition is rotation free and translation free, which once again, that's just going to be 1. Modulus elasticity is the same as it's been because we're still using that 836 steel, so 29 million, which I did get to right, good. Our minimum yield point, which is Fy, that's also determined by our 836 steel, which is 36,000 psi, which I didn't type in correctly. And our CC, which I've looked through the text and I can't find what that actually stands for. That equation, it's 126.1 for 836 steel, but it actually provides an equation of where that number comes from, and that's square root. So in Excel, to do square root, it's SQRT. So that's that times 2 times pi, which in Excel once again is pi parenthesis in parenthesis squared. And then that's times our modulus of elasticity. I'm just putting parentheses on here. That's actually not necessary, but I do it just to separate things out. And then that's going to be our minimum yield divided by our minimal yield point. And press enter. And as you see, it's 126.1. So when we go over to our solve section here, kind of got these out of order, but we're going to solve for KLR first. You'll see that referred to in a lot of these equations, but that is just the equation, is K1 times L, our height, divided by R, this one, the minimum R. So I'm going to use that one first because, like I just said, that this equation here is going to be used in a lot of the other equations. So if we solve it here, we can just click on this cell. So I'm going to press equals 1, which actually in the end doesn't really matter, but we'll use it anyways, times, it would matter if it wasn't 1, but because it's 1, it doesn't really impact our equation, times length, which that's in feet, so let's multiply that by 12, and then divided by R right here. That's why we're times it by 12, because we got 14 feet and then inches here, so let's keep them in the same units. Press enter. That's 66.14, which is similar to what the text gives. Then the next step, we're going to do factor of safety. We're going to use this in our table, this equation. Not exactly the way I'm doing it right here, but same equation. Is 5 divided by 3 plus, it's a long equation, but it's not hard to put in, 3 times a KLR, oh, I didn't press equals, there we go, KLR divided by, now I'm going to do, these parentheses do matter because we want it to divide by these two numbers multiplied by each other. So that's 8 times CC in parentheses. If I had not put that in there, that would have been 3 times D3 divided by 8 times B10 versus 3 times D3 divided by 8 times B10. Okay, that's good. These parentheses don't matter, it's just me keeping things organized for my own as I look at it. Alright, next part of the equation is KLR raised to the third, and divided by parenthesis 8 times CC raised to the third. In parentheses. Yep, and that should be the answer you get, is 1.85. There's actually going to be 2 equations we're going to use for this FA, but for the example, it's Formula 1 from your text. There's 2 formulas we would use, Formula 1 and Formula 2. There's a Formula 3, but we won't be using that for what we're doing. Let's see here. So, this one's fairly long, but it's, once again, if you get it in there right, and mind your parentheses and whatnot, it shouldn't be too hard to accomplish. So parenthesis, let's see, I'm going to do, yeah, that is 1 minus parenthesis KLR squared divided by parenthesis, this one does matter, 2 times CC squared in parenthesis, and in parenthesis. Okay, I'm going to get rid of these. This is the ones I just had on there, they don't matter, but they also don't hurt. So, like I said, I'm doing that just to kind of keep things organized as I look at it. And then one more to close off. That's the full equation there. That times our Fy divided by our factor of safety. And I do believe That is correct. Oh, it's almost there, but that's KSI. This is in PSI. So taking all of that divided by 1,000. There we go. 16.83 KSI, which is what they also have basically in the text. And then the last bit there is going to be our load. The acceptable load or allowable load is our FA here times our area there, and press enter. Yep, that's the right answer. So that's how you do the example. In my next video, I will show you how to fill out the table.